This is Professor Needing, and we are back with another Math 068. And tonight we're covering Section 7, which is statistical notation. So by now we've gotten ourselves a little familiar with the different types of categories, categorical information and quantitative information. Now we're starting to move into actually doing some analysis with these particular different things. So let's start our discussion with Section 7. And Section 7 appears, on page 46 is where it starts. Now, there's a couple of things here. And first of all, I'm going to walk through the slides with you and we'll fill them out together. And then I'll leave you with a couple of things to fill out on your own for your upload. Is that we commonly use symbols. And the reason we use symbols are basically we want things to stand for something. So we use symbol notation in mathematics as shorthand versions of words or phrases. And that's really what we're talking about when we discuss these particular things. It says very useful concept to be named by the symbols often used in equation and formulas. In these statistics, a number of symbols are taken from Greek rather than English. We tend to use Greek alphabetized values, mostly because that's the origins of some of the mathematics that we're dealing with. And because they acclimate themselves a little bit better to what we're doing and understanding as far as what they represent. It says the table below contains the most commonly used symbols, their names from the Greek alphabet and what they represent. Okay, so we're going to start at the very beginning here. So the first symbol that we're going to talk about is referred to as X bar. Now, X bar, name, X bar is a little symbol of X with a line over top of it. And that symbol itself is a mean value. And it is a statistical sample, okay? So it's important, first of all, for us to deviate between what stands for a sample and what stands for a population. And an X bar is a mean value of a sample. It is a statistic, and it's a mean statistic, but it represents only sample data, not population data. If we want to discuss population data means, we move on to what we refer to as mu. A mu value, mu, its symbol notation is here. This is the mu symbol in Greek. This is the name mu. And it stands for a mean statistic also, but it's a mean of a population. Every symbol pair we have that we're going to cover today has a sample and a population counterpart. So anytime we're dealing with the best point statistic, we're going to be talking about a sample. And you're going to hear me use those words, best point statistic. In addition, when we're looking for a parameter, a population parameter, we'll be talking about mu. Next is an S. S is a standard deviation of a sample. When we talk about variance of a piece of data, and it's in a sample piece of data, in other words, how much a piece of data can spread from the center, we refer to its standard deviation. If we're looking for a standard deviation for a population, it's referred to as a sigma. Kind of looks like a circle with a line on the top of it, sigma. Again, it's a standard deviation of a population data point. P hat. A p hat value is a p with a almost an exponent looking hat on it. We call it the caret key sometimes, over top of the p value. We call it p hat, and it's a proportion for a sample. These will come to us in a decimal, a fraction, or a percentage. All proportion values are one of those three measurements. If we're looking for the proportion in a population, it's just referred to as p value, and a p value proportional will go with a population proportion. P hat and p go together like S and sigma go together, like X bar and mu go together. Our next one is going to be for two pieces of quantitative data. Two pieces of quantitative data on a sample are going to produce an R value or an R coefficient. An R coefficient is a correlation sample. We've done this before in the calculator when we ran a plus bx, and we calculated the slope and the y-intercept, and we also got an R value. The R value is the coefficient correlation. So any of those words, R value, correlation coefficient, but R goes with a sample. If we want the R value for a population, it's referred to as rho. This is not a P. It kind of looks like a P. It's very slanty with a very big loop at the top of it. Not to be confused with a proportion. This is not the same. A rho value is a correlation population. So it's the same R value, but it goes with a rho. And it looks like kind of a P. When I generally do it, I will write rho because I don't want to confuse my bad handwriting of the P with the proportion value. You're more than welcome to write rho also. And again, those pairs go together because R correlation and rho correlation go together with sample and populations. When we talk about an n value or little n, we're talking about the number of items in a sample set of data. N is always the number of, and small n is the number of in a sample set. So that stands to reason that big N, and that's what we refer to it as big N, would be a sample number of, a set of numbers, not from a sample, but from a population. This piece of paper is highly useful to you for the remainder of the course. Take good study of it, look at it really well, know it forward and backward. Keep it off to the side until you're more familiar with all the parts of it. So now what we're going to do is we're going to run through student exercise number 2. And in student exercise number 2, we're going to do a little bit of calculating. And we're going to use all of these in order to do that. So the first one that I have here in student exercise number 2, and I'm going to highlight the things. You can see I already have the notations written down. It says that give the correct notation and representation for each numerical value in the following scenario. In a survey of randomly selected 180 college professors. So first of all, we have to realize that that was a piece of sample data. They were randomly selected and there were 180 of them. So there's many more of them. In addition to that, there's a mean calculation here, and that mean calculation is 4.5 hours per week. So if I'm dealing with a mean of a sample, I come back to my list. I find means which are either X bar or mu, and because it's a sample, I'm going to use X bar as my statistical sample. So first of all, small n, because it was a sample, is 180, because there were 180 people surveyed. X bar is my mean value, and it's 4.5. And I chose X bar because it was a sample. In problem B, researchers select a group. So again, a selected group of 2,400 people is a sample. They were selected from a small country to complete a survey. So there's many more people, or there's at least more people in the small country than just the 2,400. The results revealed that 95%, as soon as you see a percentage, you have a proportion. Remember, percentages, fractions, or decimals are in this value are always proportion. So first of all, n is equal to 2,400. The number of people surveyed was 2,400. N is 2,400. Because it's a proportion of a sample, it becomes p hat. Proportion of a sample, p hat. So my statistical notation has to include p hat. And notice I put it equal to 0.95. When we talk about a p hat value, we don't talk about the percentages. We don't talk about the fractions, even though they can be given in the written problem. We convert all of them into decimal notation. P hat equals 0.95. In letter C. Now, in this one, it's a U.S. Census report. When the U.S. Census reports, it reports on all people, because they send out the census, the assumption is everybody answers. Now, we know that's not true, but the referral is everybody. So when we talk about everybody, this is a whole population. We're looking for the mean of the whole population, and that number was 2.58 standard deviation. Excuse me. The mean was 2.58. and the standard deviation was 1.8. We don't have an n value here. It's all the people in the US. The mu, because remember, if I go back to, and I find my mean value for a population, I have to now use mu. My standard deviation for a population has to be sigma. So my mu value is 2.58, and my standard deviation, or sigma, is equal to 1.8. Letter D. I have a survey of 1,353 Americans. Well, we know there's way more than 1,353 American households. Found that 18% of the households own a computer. So my sample, 1,353, my p-hat value, 18%, converts to 0.18. It's a sample piece of data, and these are my statistics. If it said all Americans, be big N. Letter E. The average salary, notice I underline the words of all. Of all assembly line employees in a certain car manufacturer is $33,000. So if I go back to my statistical data sheet and I find the mu value for a population, I can see that the mu value is 33,000. The last one, letter F. The average late fee for 360 credit card holders. Well, 360 credit card holders is a sampling of those who hold credit cards. Those who hold credit cards, N equal 360, was found to be 56.75. Their average is always a mean, and a mean is 56.75. I would have you complete page 48, the remainder of these questions, and upload those when you get to the end of chapter 9. When you come back, we'll do chapter 8, which will continue us into population parameters and some more statistical notations.